Flash at DESY started at the beginning of this millennium as the world's first soft X-ray free electron laser. With its extremely intense and ultra-short pulses, it sheds light on the nanoscale structure and the femtosecond dynamics of matter. Since more than a decade, it allows researchers to study ultra-fast processes such as chemical reactions, magnetization phenomena, and nanoexplosions. Researchers also thoroughly investigated the nonlinear photoionization processes at that wavelength scale. In a sense, Flash is a super microscope which allows us to record high-speed movies in the nanocosmos. Flash's highly demanded form of radiation is generated as follows. Electrons are accelerated to almost the speed of light. Special arrangements of magnets called ondulators force the electrons to move along a sinusoidal course. In the curves, the fast particles emit short flashes of X-ray light. These flashes overlap and oscillate in sync to create the unique X-ray laser light.
Contrary to synchrotrons, free electron lasers are single-user machines because they require a linear accelerator to generate a sufficiently high-quality electron beam. At Flash, we now for the first time use our accelerator to drive two FEL lines. And we can do this efficiently because we use superconducting linear accelerator technology. We have a relatively long RF pulse of 800 microseconds in which we can generate up to 800 electron bunches. And this with 1 megahertz, and this is repeated with 10 hertz repetition rate of the bunch train. If we now have two FEL lines, we divide the 800 bunches into the both sections and only lose about 50 microsecond kicker rise time in between.
Flash has needed only small modifications to include Flash 2 into the machine. Mainly a so-called kicker septum has been installed behind the accelerator. A second photoinjector laser allows to vary the laser parameters independently of Flash 1. Flash 2 can though be run with its own number of pulses and pulse spacing. Also, the pulse length can be changed independently by varying the electron bunch charge.
Flash 2 uses variable gap undulators, and this way the wavelength can be chosen largely independent of Flash 1. Photon diagnostics are used to measure online intensity, wavelength, beam position and pointing for the operators to set up the FEL beam as well as for the users to analyze the data. Since spring 2016 we have two Flash 2 beam lines operational with one permanent end station. And this way we have demonstrated simultaneous operation of two FEL lines driven by one linear accelerator. And this will pave the way towards multi-user FEL facilities.